Hi and welcome back to Learn Python by Doing number 9. So today we're going to talk about generators, but first let's review what we did last time. So we were creating our own iterators, and remember that we had to create this class power of 2, and in order to create an iterator we have to specify this magic method called iter, and we have also to implement this next method. So by implementing this iter, then we can pass the instance of this class to the iter function, and with this next magic method then we can use this next to that iterator. So that's how we created our own iterators. And one thing I want to mention before learning generators is that iterators can be infinite. That means that we can create powers of 2 an infinite number of times. So we don't have this stop iteration in that case. So let's modify this a little bit. So we're going to get rid of this condition. Okay, and also in the constructor we won't have a maximum because we're going to have an infinite number of powers of 2. So in order for the constructor to do nothing, we just say pass. Okay, so now we don't have here a maximum, but we can still pass this to the iter function, and we can execute this next an infinite number of times, and we're going to get 32, 64, and all of the powers of 2 available. Okay, but you have to be very careful when doing this, because suppose you want to have an iterator that returns the number of all the primes, yeah, the prime numbers, for example. So, as you know, prime numbers are infinite, but checking if if a number is prime is very expensive. There are very advanced methods to check if a number is probably a prime or not, but that's another story. In order to exactly check if a number is prime or not, that's a very expensive task to do. So you can run out of memory, and so you have to be very careful when doing these infinite iterators. Okay, so now that we have talked about iterators, let's talk about an easier way to implement them. So these are generators. As I say here in the first point, they are a simple way of creating iterators, because all the work, implementing the iter and the next magic methods are handled automatically by generators. And they are easy to implement. We just have to create functions that returns elements with yield, with this keyword yield, instead of return. Okay, so these generators, they can contain one or more yield statements, and when called it returns an object which is an iterator, but does not start the execution immediately. Okay, so we're going to see this in a moment. And the other thing we have to note is that once the function yields an element, the function stops. It is paused, and the control is transferred to the caller. Again, we're going to see this with an example. And one of the most powerful things with generators is that local variables, so variables that are inside those functions, and their states are remembered between successive calls. Okay, so let's implement these powers of 2 with a function. Okay, so we define our normal function. So we're going to call it powers of 2. Okay, so let's first create a version where we have a maximum. So we are going to pass a maximum to this function, and we are going to implement here a for loop. So for I in range maximum, we're going to say maximum plus 1, so we include the maximum. Then instead of returning, we're going to say yield to the power of I. Okay, so now let's see this in action. So powers, I'm going to name this variable powers of 2 and until 5. Okay, so now let's see, we can apply the next function directly to powers, and now it's 1, 2, 4, 8, 16, 32, and the next time is going to raise this stop iteration. So as you can see, this does the same as this, but this is easier to implement. Okay, and well, this is the version where we have a maximum, but we can have also the version where we don't have a maximum, so like the one that is implemented right now. So here we just replace the for loop with a while and initialize this variable I, and after this we simply increment the values of I by 1. Okay, so now this doesn't need the maximum, and next 4, 8, 16, 32, 64, and so on. Okay, so note one important thing here. Note that what will have happened if I had a normal function here. Okay, so maybe this while true wouldn't have stopped, so I was caught in an infinite loop, but this is not the case. Once the function reaches this yield statement, it stops, like I said in this point here. Once the function yields, the function is paused and the control is transferred to the caller. In this case, the caller is powers, this variable powers. And so that's what this point means, that the function is paused or stopped. Okay, so this is how you implement generators. Believe me, they are extremely important, and they are not only used in Python, they are also used in JavaScript, for example, for a library called Redux Saga, if you have heard of it. Generators are extremely important for asynchronous things that we are not going to discuss in this video. So we're going to discuss another thing, which are generator expressions. So it's even an easier way to construct generators. So let's recall how we create a list. So now we're not going to create our fruits list this time. We're going to simply declare a list of numbers. So 3, 6, 8, I don't know. Okay, so a generator can be these powers. I'm going to, so instead of using brackets, we're going to use parentheses, or we're going to say x squared for x in numbers. Okay, so this is not a tuple. This is, we can say, a generator expression, which resembles a lot to list or dictionary comprehensions. And this is going to be a generator. Powers is going to be a generator. So let's see. Now we can call next powers. And as you can see, it returned 9, which is 3 squared. Now it's 36, which is 6 squared, and now 64, which is 8 squared. If we call it one more time, then we get our well-known stop iteration exception. Okay, so why we should use generators, because they are easier to implement than iterators. So, okay, now it's fixed. Easier to implement than iterators. They are memory efficient because generators returns elements just when you need them. So just when you call them. They don't create the entire list. For example, in this case, the generator isn't creating 9, 36, and 64 at once. It's creating those elements just when they are called. Okay, so that's why they are memory efficient. And they are also excellent to generate infinite streams like we saw in this example here. So again, you have to be careful because it doesn't mean that, for example, finding the next prime number is not going to take a lot of time, because you have to check if it's divisible by a lot of numbers. So you have to be careful with this. But besides that, they're excellent to generate infinite streams, and they can be pipelines. So what do I mean by that? So let's take this code here and put it here. Okay, and now let's create this generator here, and let's say x plus 2 for x in powers. Okay, so now let's see what the result is going to be. Okay, so next additions, as you can see, it's 11. So what happened here? We first did the calculation, x squared, which is 3 squared, 9. And then we did the other calculation, which is adding by 2. So 9 plus 2 is obviously 11. Let's see the other element, 38. So 36 plus 2, 38, and 66, which is 64 by 2. So this is what a pipeline is, that we can first do this and then do this, and result is going to be coherent. Okay, so I repeat, generators are extremely important. They are also used for other more advanced things like graph theory. I have seen lots of algorithms that used generators. For example, the breadth first search, if I'm correct, uses generators to find the shortest path between two nodes. Another example is what I told you earlier, Redux sagas, to manage some actions asynchronously. So this is pure JavaScript bar, but it's okay. And well, they are extremely useful, and I hope you learn how to do now iterators easier and, well, quicker. See you in the next video.